In this video, we'll talk about what is a function. So a function is a rule that describes how one thing depends on another. So, if you had skydivers falling, we have a rule for that. We can mathematically model the rate at which they fall, which as a result will help them know when to pull their parachute so they don't just smash into the ground. We'll talk about examples of functions, the definition of the function, and how to evaluate the function. So first, let's just think about some examples. What are things that depend on other things? Something that comes to mind for me is height depends on age. The area of a circle, A, depends on the radius of that circle, R. Temperature depends on the time of day, T. In other words, the output depends on the input. It's often useful for us to think of a function as kind of a machine. So I've drawn you this beautiful function machine, and we could give it something, maybe 3, and it would give us out 72. We could give it 8, and it would give us 3. We could give it time of day, and it would give us temperature. We could give it anything from the blue circle. We apply the function, we crank the machine, and it gives us out something that falls into the green circle. So kind of formally, a function f is a rule that assigns each element x in some set A exactly one element called f of x in a set B. In other words, the range R of f is the set of f of x such that x is in the domain D of f, which is just to say that the domain is all of the inputs x for our f, the machine, and the range is all the outputs, f of x of f. So this is to say that we have one set of things, we grab something in it, we put it through the machine, and we get something out of it that falls into the set B. As an example, let's say that we have some function. We've got a mysterious function. We don't know what it is, but we'll figure it out. Let's say I give them the function 1 and we get out 1. I give the function 2 and we get out 4. We give it 3, I get 9, 4, I get 16. So you may have guessed that the pattern here is that the function is square the input. We can write that like this. So we need some letter. We usually use F, G, or H to indicate function. So we'll use F. We need to say we're plugging in something into it. So we add parentheses and put X. We read this as f of x. You might also see f at x or other things like that. Conventionally, most people say f of x. And then we need to write how we're applying this rule to x. In this case, we're squaring the input x, so we can write just x squared. F of x equals x squared. Often, it's convenient to write f of x equals y. And this is important. This kind of connects us back to our algebraic expressions, right? Before, we didn't have a function, but turns out that they can be thought of very similarly. So if I give f 5, we write this as 5 squared, which gives us 25. if I say f of 6, we plug in 6 for whenever we see an x. There's only one x here, so we get 6 squared equals 36, etc. and so forth. So this is a function. We take the blue circle and we apply the function f to things in the blue circle. Maybe we got a bunch of x's in here. And we get things that fall into the green circle. Now, again, it's really important to say that every x has exactly one y. If we plug in 1 into our function and get 2, and then plug in 8 into the function and get 2, we're going to have a problem. We'll talk about this more later, but it's just important to remember that when we apply f to some set of things, we get out some other set of things. The output depends upon the input.